This is an introduction to the design of individual projects. All projects follow the same basic design, with an introduction, the purpose of the project, concepts, an outline, and standards. Projects offer an essential question, student scenario to set the stage, a daily guide for teachers, vocabulary, and resources. With the Siemens Engineering Design curriculum, it's important to note there's a teacher version and a student version. The standards are omitted from the student version to simplify their navigation through each project. So let's look at an example of a typical project. In this case, the students are tasked with designing a water bottle. The introduction has a little background and notes that consumers today have a lot of choices. Containers can come in all sorts of colors, shapes, and sizes. It tasks the students with designing a beverage container to hold a specific volume and fit the standard cup holder in a vehicle. That is the problem they need to solve. The purpose of the project lays out what students will learn. In this case, how to use a mathematical formula to calculate volume. Then, how to calculate the dimensions of the container from the specified volume. Students will get introduced to 3D modeling concepts and use the different features of the current software. This helps them to document their designs. The techniques they learn here can be used throughout this course. There's a list of concepts for each project. These are the big ideas. So in this case, one of the big concepts is that products, like water bottles, are made to certain standardized increments and sizes. Another concept is that engineers frequently use math formulas when designing products. The outline shows where this project fits in the total scheme of the course. It allows teachers to see how major components such as documentation develop sequentially during the course, while helping students incorporate different beverage types and different volume formulas. In this case, modeling is critical. How will it be applied? And what needs to be communicated about the documentation of the project and the 3D print of the bottle design? Each project has a series of standards built in. There are career and technical standards, college and career readiness math standards, and even reading and writing standards. It's important to note that we use next-generation science standards. The projects engage students in the scientific and engineering practices, cross-cutting concepts, and core ideas. There are formative and summative assessments built in. For each project, the students will create design briefs, engineering reports, and document their work in a wide variety of ways. This is one formative assessment. The teacher must keep track of progress, providing formative assessment in the form of feedback, and help the students reflect on their work. They should ask questions like, did I do X task correctly? Could I have done it differently and gotten better results? Each project has rubrics that are associated with it so students can see in advance what is expected. There is also a daily plan for how the work will be accomplished. On the first day, the project starts by looking at the essential question. How do we design a modern and practical beverage container that will hold a specified volume? The student is presented with a scenario. They are a package designer, and they must submit plans for a product line of stackable beverage containers that could be made from several different materials. The scenario lays out the process, what needs to be created, and the deliverables. In this case, that is, engineering notebook entries, CAD model of the containers, 3D printed models, outline of an engineering report that includes 3D images and working drawings, and a final presentation of the development process. This project takes 13 days. Students will keep their engineering notebook current as they work. The teacher will provide access to video tutorials on topics like basic 3D commands or how to edit and develop 3D designs. There are also Siemens Solid Edge video resources for further information. For this project, they might want to learn about how to sketch or extrude plastic. There is also a resource section where students can see other container designs or learn more about volume formulas. These are specific to this project, but there are also resources which are more general in nature. The Siemens Engineering Design curriculum includes a range of individual projects that have been carefully designed, and start with simple ones like designing a nameplate, and then become progressively more complex. This helps students build on their learning and grow with each experience.